Okay, so as mentioned in the last part, just abruptly cut off, all new instances are given an instance name, an instance number, in fact, by Animate, which we can access or we can create our own. It would be instance 0, instance 1, instance 2, just counting up numerically, essentially, which is quite useful when you're bringing in multiples. And we've got no need to reference specific instances in the map itself for now. We're just creating a map. So once we've added it to the display list and it's visible, I'm then going to add an event listener so that based upon the frame rate, 24, 30 frames per second, whatever's set as the default, it will run the function drag tile, which we'll explain in a short period. We also assign a map reference. So that's a value that we're going to put into the map array to represent what each location contains in terms of an item. Could that be a grass tile? Could it be a coin? Could it be a piece of wall? And so on and so forth. Break just stops the rest of the function, the rest of the switch case statement running, because there's no need to check the rest of the cases. We've already found the correct one. So it's pretty efficient because it will just check the specific line, the next line till it reaches the correct one, and then ignore all else. And we've just got to make sure that we've correctly closed this switch case. That's that one there. And then this bracket closes the function entirely. And you'll notice that you actually get a nice little hint from Animate in terms of code. If you notice that red line that goes all the way up, and it shows you the corresponding brackets, the ones that are related from line 46, the start of the function, down to line 123, in this case, the close of the function. And it seems like a lot of code, but when really we're just repeating the same sort of 5 or 6 lines, it's not actually that lengthy. It can be quite quick to put together. Okay, so the drag tile event, which is running on enter frame, therefore the data type we're listening for is event rather than mouse event. We're using to snap the tile to a specific location rather than moving around the screen fluidly in this case. So we store a location of X and Y, do a little bit of data manipulation before we then set the position of the target, whatever's being clicked and dragged, on the stage. So what we're doing is we're taking the current mouse X position, the current mouse Y position, and we're dividing it by 64, that magic number in this case, because that's the tile size, width and height both of. We're also then multiplying by 64. But why would we do that? The reason we do that is because we use a function called math.floor. So that will round down. It will always make sure that it's rounded. So if we say, for instance, have a look at the numbers for that, and just get this open permanently for a little bit. So for example, 539, and we divide that by 64, would give us a remainder of 42, or 0.42 in this case, which is essentially 42%. What we would like, or what we're interested in, is the 8. So if we just take the 8 and then times that by 64, it will give us 512. And so by doing so, we're getting a whole number. And not only that, we're creating numbers that only fit into the 64 times table, which is important because of the width of our tiles. 64 is the right-hand edge of the first tile. 128 is the right-hand edge of the second tile. However, on the flip, 64 is the left-hand edge of the second tile, and that's what we're using to position it, the left-hand edge, because of our registration point, which was created much earlier on. But I can show that for true if we just double-click on any movie clip that we've created, and just get rid of the code for a second. You will see here, top left-hand corner, that cross, which denotes the registration point of that movie clip. So that's where the numbers are coming from, the measurements. And we've also got a better look at it here going on, because the registration points have all the symbols are at top left corner. We've done that deliberately in this case because it works well for the maths that we're using. It keeps it simple, or simple as possible anyway. We then position based upon those new values, so make sure it snaps. And when we look at that in working order, it means that whenever I move the mouse, it will only position the tile in the location of an existing tile, and it won't let me put it in between them. It might go a little bit funny if we're on around a point, as so, and that's much more useful in this context. Okay, we also then add the event listener mouse up to stop the drag tile. This probably could be a bit more efficiently placed somewhere else, but for now we'll live with that. The next function, stopping the drag tile, is listening for a mouse event, and it's got an if-else statement. We can see that here. Here's the if leading up to that bracket there, and then the else. All it's doing is checking the position of the tile and making sure it's on the stage, or the stage that we're defining as being up to 640. If it's 640 or more, then it's off the stage and it won't be positioned. What it will do is it will follow the else statement, currently tracing out true, but I'll just comment that out, and then removing the child from the stage. So it's getting rid of that specific instance that we've created because it's not where it's supposed to be. If that is true and it's less than 639, then it will be positioned based upon the snapping in the previous function. And also, we will remove the event listener because we've let go of the mouse button. So we'll get rid of drag tile. It will cease to move. We're positioning it, depositing it where it's supposed to be. So we've got two variables, current y, current x. And again, it's the same as using the snapping function. We're taking its current position, we're dividing by the tile width to give us a specific location. So, for example, I mentioned before 512, which we know is 8 times 64. But if I divide it by 64 to make sure, then that will mean that it goes in location 8 of the map on whichever row or column. So these numbers are basically taking the tile's position, dividing it down into a number less than 10 to make sure it fits in to our map array. So current y in that example could be 8, 0. But we're always dealing with the small numbers and we can gauge the exact position. We then set the value of that location in the map array to equal the map reference. So the map reference will be the number we assigned in the switch case function, such as 9 for treasure, 8 for row 2. Now in the output window, this is not necessarily as visually obvious as when we first defined the map earlier on, but it's still useful when we're testing. Then the last few lines are essentially just event listeners for when we press the mouse down. We're not interested in click because that would mean that the mouse has gone down and then up again. We just want when the mouse is being pressed to start drag tile, which allows us to then create the event for moving around the new instance that we create. And as we've described, the process. So 155 lines in code, it's not actually that much because a lot of it is repeated. It's copied and pasted and then new instance names attached. So if we just check that out one last time. So for example, we'll take the treasure chest and we would expect that to be the very last value in the array, which we know to be a 9. And let's say the road there, and let's just take a look at the array. Drag this across to the side. And you will see there the very last value is 9, and then it's 7 and 9, based upon the switch case statement. And that's where we'll end for now.